Have you ever questioned the shape of the Earth? It's a query that might seem odd to some, as the idea of a spherical Earth has been widely accepted for centuries. However, the flat Earth belief, the notion that our planet is not a globe but a flat disk, has a long history and has surprisingly resurfaced in recent times. Ancient cultures, from the Greeks to the Chinese, held a variety of beliefs about the shape of the Earth. The concept of a flat Earth was prevalent among many early civilizations. Fast forward to today, and you'll find a host of famous advocates for the flat Earth theory, from reality TV stars to professional athletes, stoking controversy and prompting us to revisit this debate. Yet despite the noise, the scientific community overwhelmingly supports the round Earth theory. Why is that? Stay tuned as we explore the evidence, debunk the myths, and delve into the fascinating world of Earth's shape. Let's start with the most straightforward evidence: the Earth's curvature. It's something we don't typically notice in our day-to-day lives, but it's always there, subtly shaping our perception of the world. You see, Earth's curvature is observable in everyday situations. Imagine standing at the beach, watching a ship sail away. As it moves farther from shore, the ship doesn't just get smaller, it appears to sink, beginning from the hull and eventually leaving only the top of the mast visible. This isn't due to some magical sinking property of ships, but rather the curve of the Earth obscuring the vessel as it sails away. Now picture this. You're standing on a hill overlooking a city skyline. The buildings seem to rise from the ground as you approach, but they've been there all along. What's changing is your viewing angle. As you get closer, you're able to see over the curve of the Earth, revealing more of the buildings. Consider a hot air balloon ride. As you ascend, you don't just see more because you're higher up. You see more because the curve of the Earth allows you to. The higher you go, the further you see. And it's not just a matter of altitude, but the shape of the Earth itself. Even the way we view the stars speaks to the Earth's curvature. As we move from one location to another, the set of visible stars changes. This wouldn't be the case if Earth was flat. Instead, we'd see the same stars no matter where we are. In essence, these observations all point to the same conclusion. Our Earth isn't flat, but a sphere. It's a concept that's been accepted for over 2,000 years, ever since the ancient Greeks calculated Earth's circumference using nothing more than shadows and simple geometry. So if the Earth is flat, why can't we see everything from a high point? The answer lies in the curve. It may be subtle, but it's there, shaping our world and our view of it. The Earth's curvature, it's not just a theory, it's a fact. If you're enjoying the video so far, like the video, comment your thoughts, subscribe to the channel and share to spread awareness. Now consider circumnavigation, the process of traveling around the Earth. It's a concept that's been explored for centuries, with notable figures like Ferdinand Magellan and Sir Francis Drake making history with their epic voyages. These trips, in essence, involved going in one direction until they ended up right back where they started. Something you'd only expect on a round planet. Let's delve into some of the historical examples. Take Magellan's voyage in the 16th century. His fleet set off from Spain, moved westward, and despite numerous challenges, one of his ships eventually returned to Spain. This journey alone provides compelling evidence of a round Earth, as the route would be inexplicable on a flat model. Now let's bring things closer to the present day. The advent of aviation gave us a new perspective on the Earth, quite literally. Airplanes fly along specific routes known as flight paths, which are designed based on the Earth's curvature. Why? Because it's the quickest and most fuel-efficient way to travel between 2 points. Consider a flight from Los Angeles to Tokyo. The shortest route, known as the Great Circle route, takes the plane over the Pacific close to Alaska. On a flat map, this might seem like a detour, but on a globe, it's the most direct path. And it's not just this route. Thousands of flights every day follow similar paths, all of which are predicated on the Earth being round. Imagine for a moment if the Earth were flat. These flight paths would look drastically different, and historical circumnavigations would be impossible to explain, but the evidence is clear and consistent. From the epic voyages of historical explorers to the flight paths of modern aircraft, circumnavigation provides us with undeniable proof of a round Earth.
If the Earth was flat, wouldn't these journeys look vastly different?
But what about the arguments made by flat Earth proponents, you might ask? Well, let's dive into some of the most common flat Earth myths and see how they hold up under the lens of scientific scrutiny. First up, we have the argument about the movement of the sun and moon. Flat Earth proponents often assert that the sun and moon move in circles above the flat Earth. Yet this theory doesn't account for the observed phenomena such as the changing size of the sun and moon in the sky, or the differing lengths of day and night throughout the year. In contrast, the round Earth theory elegantly explains these phenomena. The Earth's rotation causes the sun and moon to rise and set, while its tilt and orbit around the sun account for the changing seasons and length of day and night. Next, let's debunk the myth about gravity. Flat Earth proponents claim that objects don't fall to the ground because of gravity, but rather because they are denser than the air around them. However, this explanation falls short when we consider the concept of weightlessness. Astronauts in space experience weightlessness because they are in free fall, constantly falling towards the Earth, but also moving forward fast enough that they keep missing it. This phenomenon can only occur if the Earth is round and gravity is pulling everything towards its center. Now let's tackle the myth about the appearance of stars in the night sky. Flat Earth proponents argue that if the Earth were round, we wouldn't be able to see the same constellations all year round. However, this argument disregards the Earth's annual orbit around the Sun. As the Earth moves, our perspective of the night sky shifts, causing different constellations to become visible at different times of the year. Moreover, some stars are visible year-round because they are located near the north or south pole of the sky, around which all other stars appear to rotate. Finally, we have the myth that the Earth looks and feels flat. This perception is due to the vastness of the Earth compared to our size. The curvature of the Earth is difficult to perceive from the ground, but it becomes apparent when we view the Earth from a higher altitude, as astronauts do from space, or when we observe a ship disappearing hull first over the horizon. So it seems these flat Earth myths crumble under scientific scrutiny. The round Earth theory not only explains the phenomena we observe, but also makes accurate predictions about the world, a key requirement for a successful scientific theory. The flat Earth theory, on the other hand, struggles to explain these phenomena and fails to make accurate predictions. This contrast highlights the importance of using scientific principles to evaluate claims about the world around us. So why does the flat Earth belief persist? Well, it's often a matter of scientific literacy. In a world brimming with information, the ability to separate fact from fiction is more crucial than ever. Scientific literacy isn't just about understanding complex equations or memorizing the periodic table. It's about developing a critical mindset. It's about asking questions, seeking evidence, and drawing conclusions based on that evidence. It's about being able to discern between credible sources and those that peddle pseudoscience. The belief in a flat Earth isn't just a harmless quirk, it's a symptom of a larger issue. The spread of misinformation can lead to harmful decisions and a mistrust of science. And in an era where we face challenges like climate change and a global pandemic, that mistrust can have real-world consequences. So let's embrace a scientific mindset, not because it's trendy, but because it's necessary. Remember, science doesn't depend on belief, it relies on evidence. In conclusion, the Earth is round. No, this is not a whimsical declaration, it's a scientific consensus. This isn't based merely on theories or assumptions, but on solid, irrefutable evidence that has been gathered and corroborated over centuries. We've journeyed through the curvature of the Earth, observed ships disappearing over the horizon, and understood the concept of circumnavigation. We've debunked myths, misconceptions, and shattered the illusions that sometimes cloud our understanding. We've seen time and again that science stands tall, resilient in the face of skepticism. This is not a debate between two valid viewpoints, but a confrontation between scientific truth and unfounded myth. The Earth's roundness is not an idea open to negotiation or personal interpretation. It's a fact, grounded in evidence and proven by the rigorous standards of scientific inquiry. The Earth is round. That's not a belief, it's a fact. And facts, dear viewer, don't require your belief to be true.